Imagine a future where doctors can send microscopic machines, so small you'd need a powerful microscope just to see them, directly into your body. These aren't just any machines, they're tiny robots, or nanobots, designed to travel through your bloodstream and reach places that even the most skilled surgeon's hands could never touch. Their mission? To fix problems from the inside out, repairing damaged tissues, cleaning up blockages, or even hunting down harmful cells, all at a microscopic level. It might sound like something straight out of a science fiction movie, but this technology is quickly becoming a reality. Thanks to advances in nanomedicine, scientists are developing these incredible machines to perform tasks that were once impossible. These nanobots are invisible to the naked eye, yet they're engineered for astonishingly precise jobs inside our bodies, like delivering medicine to a single cell or repairing a tiny tear in a blood vessel. Instead of relying on surgery or medications that affect the entire body, nanobots could target only the problem area. Imagine a nanobot seeking out and destroying a tumor cell, or delivering a life-saving drug exactly where it's needed, leaving healthy cells untouched. This approach could completely transform healthcare, making treatments not only smarter and more effective, but also far less invasive and with fewer side effects. Around the world, teams of scientists and engineers are already building and testing these tiny machines. They're unlocking new ways to fight cancer, clear dangerous artery blockages, and even battle infections that resist traditional antibiotics. We're on the brink of an era where doctors will have microscopic helpers working tirelessly inside us, performing tasks we once thought were impossible. So, let's take a closer look at the incredible world of medical nanobots and discover how these smallest of machines could help solve some of our biggest health challenges, changing the future of medicine forever. So, what exactly are nanobots? The word itself might sound like something out of a science fiction movie, but nanobots are very real, and they're at the cutting edge of science and technology. Nano means 1/billionth, so a nanometer is 1/billionth of a meter, smaller than a strand of DNA, and far tinier than a single cell in your body. To put it in perspective, if a nanobot were the size of a soccer ball, then a soccer ball would be as big as the Earth. Nanobots are machines built at this incredibly small scale, often constructed from molecules or even biological materials like DNA. Scientists can design these tiny machines to perform specific tasks, and sometimes they're made from the very building blocks of life itself. For example, researchers can fold DNA into precise shapes, creating tiny containers that can carry medicine directly to where it's needed in the body. Some nanobots are made with magnetic materials, allowing doctors to steer them using external magnets, almost like remote-controlled submarines navigating through your bloodstream. Imagine a nanobot programmed to recognize cancer cells. It could travel through your body, find those cells, and then release a drug exactly where it's needed, or even light up to help doctors spot the problem. This level of precision could revolutionize how we treat diseases. But building machines at this scale is a massive challenge. Scientists have to use the principles of chemistry, biology, and physics to carefully assemble these tiny agents, making sure every molecule is in the right place. It's a bit like building with the world's smallest Lego bricks, snapping together molecules one by one to create a functioning machine. Every piece has to fit perfectly, or the nanobot won't work as intended. The field of nanobot research is evolving at an incredible pace. New techniques for building and controlling these machines are being developed all the time, leading to more advanced and versatile nanobots with each passing year. These machines are engineered for specific tasks, just like big robots, but on a molecular level. Some are designed to repair tissues, others to deliver drugs, and some can even help diagnose diseases by detecting chemical signals in the body. The possibilities for medicine are almost limitless. As we learn more about how to design and control nanobots, we could see treatments for diseases that were once thought impossible to cure, all thanks to these tiny, powerful machines. How do nanobots travel inside the body? It's a fascinating question, because these tiny machines face a world that's completely different from what we experience. At the scale of a nanobot, the bloodstream is like a raging river, and every cell or molecule is a massive obstacle. So, how do they navigate this microscopic landscape? The simplest way is to inject them into the bloodstream, letting them float to their target. Just like a leaf drifting down a stream, some nanobots simply go with the flow, carried along by the movement of blood. This passive approach is easy, but it means the nanobots have little control over where they end up, relying on chance and the natural currents of the body. For more control, some nanobots are designed with tiny corkscrew tails, inspired by the way bacteria swim. These tails spin, powered by chemical reactions, allowing the nanobots to propel themselves through thick fluids. Others can be steered from outside the body using magnetic fields. Imagine a doctor guiding them with a joystick, almost like playing a video game, but with real lives at stake. Some researchers have taken inspiration from nature itself, using bacteria as taxis. By attaching nanobots to these natural swimmers, scientists can hitch a ride to hard-to-reach places. The bacteria instinctively move towards certain chemicals or environments, carrying their nanobot passengers directly to the target, like a microscopic delivery service. Once the nanobots arrive at their destination, they often need a signal to start their work. This can be a flash of light, a change in temperature, or even a specific chemical cue. These triggers act like a green light, telling the nanobot it's time to get to work, whether that means releasing medicine, repairing tissue, or collecting data. But the journey isn't easy. The body's immune system is always on the lookout for invaders, ready to attack anything unfamiliar. To avoid detection, nanobots are often coated with special materials that disguise them as friendly cells. This camouflage helps them blend in, so they can move through the body without being destroyed. This stealth technology is crucial. It lets nanobots travel safely and reach their target, slipping past the body's defenses. Without it, most nanobots would be eliminated before they could do any good. It's a microscopic game of hide and seek, with high stakes for our health. The nanobots must outsmart the immune system, dodging white blood cells and other defenses as they make their way to their goal. The journey and survival of nanobots are just as important as their mission. Every step, from traveling through the bloodstream to avoiding immune attacks, is a challenge. But with clever engineering and a bit of inspiration from nature, these little machines are learning to navigate the body's complex landscape, bringing us closer to a future where medicine can work at the tiniest scale. One of the most exciting uses for nanobots is fighting cancer. Unlike chemotherapy, which harms healthy cells, nanobots can target only cancer cells using special seekers that lock onto unique proteins. Once attached, they release medicine directly into the tumor, minimizing side effects and maximizing effectiveness. Some nanobots can even heat up when activated by light or magnets, destroying cancer cells with precision hypothermia. This targeted approach is a leap forward in precision medicine. Nanobots could make cancer treatment more effective and far less painful. It's about finding and attacking the enemy with incredible accuracy. The future of cancer therapy could be microscopic and highly personal. Blood clots can cause strokes or heart attacks, and current treatments can be risky. Nanobots could patrol the bloodstream, programmed to recognize and attack clots directly. Some carry clot-dissolving drugs, releasing them only when attached to a clot, reducing side effects. Others act like tiny drills, guided by magnets to physically clear blockages and restore blood flow. This could save lives in emergencies, where every second counts. Targeted nanobot treatments mean faster, safer, and more precise care. It's like having a tiny plumber on call inside your arteries. Nanobots could keep our internal highways clear and flowing. Superbugs and tough infections are a growing problem, but nanobots could be a new weapon. Instead of flooding the body with antibiotics, nanobots could hunt down bacteria and deliver drugs directly to them. Some nanobots can be activated by light to release reactive oxygen species, killing bacteria without drugs. Others physically rip holes in bacterial walls, making resistance nearly impossible. Nanobots could also sterilize hospital surfaces or medical implants, preventing infections before they start. This technology could protect us both inside and outside the body. It's about creating a hostile environment for harmful microbes. Nanobots could be our best defense against infection. Nanobots bring precision to medicine, like swapping a fire hose for a squirt gun. They deliver treatment exactly where it's needed, reducing side effects and speeding up recovery. Instead of surgery, a simple injection could let nanobots do the work internally. They could also revolutionize diagnosis, acting as tiny sensors to detect disease early and send alerts to your smartwatch. Early detection means better outcomes and true prevention. As the technology matures, treatments could become more affordable and accessible worldwide. Nanobots could make top-level care available to more people, creating a healthier future. That's the power of tiny machines. With great power comes great responsibility. Nanobots raise big questions. Safety is key. What are they made of, and how do we remove them after their job is done? Control is crucial. We need to ensure nanobots only act where and when we want, with reliable off switches. The immune system might attack them, so extensive testing is needed to ensure safety for everyone. Ethical questions remain. Who gets access, and how do we use this technology responsibly? As we move forward, careful research and public discussion will guide nanomedicine's future. We've explored the world of nanobots, a medical revolution in the making. These tiny machines could transform hospitals, replacing risky surgeries with simple injections and shrinking recovery times. Doctors will have powerful new tools for early diagnosis and targeted treatment. The challenges are real, but the potential to save lives and reduce suffering is enormous. The future of medicine is about thinking smaller, armies of nanobots patrolling our bodies, fixing problems from the inside out. It's a big idea on a tiny scale, with the power to change our world. Science is cool,